Happy afternoon, student. Dear student, we will explain the question on chapter wave optics here. Before that, I am going to tell you some points related with HSC board exam. HSC board exam has declared so many good things for you. They are beneficial for you. First one is, in this pandemic situation, your writing practice is very less. Therefore, half hour is increased for board paper. Second one is, you know that 25% syllabus is deleted for each subject, and it is very good opportunity to increase your score. And third one is, for each chapter they are given question bank in PDF form. Therefore, you will get the guideline. Therefore, don't be afraid. Without any tension, you can face the board exam. ओके, त्यामुळं कोणीही बोर्ड एक्झामला घाबरायचं कारण नाही आहे. सगळ्यांनी व्यवस्थित आपले पेपर हे द्यायचे आहेत. तुम्हाला सर्वांना गाईडलाईन क्वेश्चन्स हे दिलेले आहेत. Therefore, let us solve the MCQs on chapter wave optics. First one, when light travels from an optically rare medium to an optically denser medium, the speed decreases because of change in, first option is wavelength, frequency, amplitude, and fourth one is phase. You know this very well. When light travels from optically rare medium to optically denser medium, its speed changes because of its wavelength. Therefore, option A is the correct MCQ for MCQ 1. Okay, then MCQ second. Light of wavelength 5000 angstrom falls on a plane reflecting surface. The frequency of reflected light is, here we have given the wavelength, and this wavelength is 5000 angstrom. Therefore, convert this lambda into meter. Therefore, it becomes 5 into 10 raised to minus 7 meter. Okay, and we have to calculate the frequency. Formula is, you know this very well, nu is equal to the c upon lambda. C means velocity of light. It is equal to the 3 into 10 raised to 8 meter per second, and lambda is the 5 into 10 raised to minus 7. Therefore, it becomes 0.6 into 10 raised to 15 hertz, and therefore it is similar to the 6 into 10 raised to 14 hertz. Okay, then next one. Light follows wave nature because light rays travel in a straight line. Light exhibits the phenomena of reflection and refraction. Light exhibits the phenomena of interference. Light causes the phenomena of photoelectric effect. Wave nature means it is related to the interference. Therefore, option C is correct. Light exhibits the phenomena of interference. Then fourth one, Young's double slit experiment is carried out using green, red, blue light, one color at a time. The fringe width recorded are WG, means width for green color, WR width for red color, and WB for width for blue color. Then the option C is the correct option. Okay, sorry, D is the correct option. width of the red light is greater than the width of the green light, and which is greater than the width of the blue light, because the wavelength of red light is greater than the wavelength of green light, and which is greater than the wavelength of the blue light. Then next one, question number 5. The path difference between the two waves meeting at a point is 11 by 4 lambda. The phase difference between the two waves is 11 pi upon 4, 11 pi upon 2, 11 pi and 22 pi. Here you should know the relationship between the phase difference and path difference. Then it is very simple. What is the relation? Phase difference is equal to the 2 pi upon lambda into the path difference. Therefore, phase difference is equal to the 2 pi upon lambda into the 11 by 4, and if you calculate this, lambda get cancelled, 2 get cancelled with this 4, 2, and therefore answer will be the B, 11 pi upon 2. Okay, next, which of the following can't produce two coherent sources? Then first one is the Light's mirror, Fresnel prism, C is the X double slit, and fourth is prism. Then you know Light's mirror produces the coherent sources, Fresnel biprism produces the coherent sources, and Young's double slit experiment also produces the coherent sources. Only the prism can't produce the coherent sources. Therefore, option D is the correct. Next, the bending of a light around the corners of obstacle is called refraction, diffraction, refraction and interference. This is the straightforward definition. The bending of a beam of light around the corners of obstacle is called as a diffraction. Then question number 8. In a single slit diffraction pattern, the first minima obtained with a red light of wavelength 6600 angstrom coincide with the first maxima of some other wavelength lambda, then it is. But how to solve this problem? In this problem, in a single slit diffraction experiment, position of minima is, formula is d sin theta is equal to n lambda. Then for first minima, d sin theta is equal to the lambda. n ची व्हॅल्यू काय असणार आहे? 1 असणार आहे. Therefore, sin theta is equal to the lambda r upon d. And as the first maxima is midway between the first and second minima for wavelength lambda dash, sin theta dash is equal to the 3 lambda dash upon 2d. And therefore, according to the given condition, sin theta is equal to the sin theta dash, and therefore lambda dash is equal to the 2 by 3 into the lambda r, and therefore lambda dash is equal to the 4400 angstrom. Therefore option D is the correct option. Okay, then next point is the very short answer. Each question has a 1 mark. First, what is the shape of wavefront on earth for sunlight? The shape of the wavefront on earth for sunlight is a plane wavefront. पहिल्यांदा आपल्याला सनलाईट पासून ऑफकोर्स काय मिळतोय? स्पेरिकल वेव्हफ्रंट मिळतोय. परंतु पृथ्वीवर येऊस्तोवर जो काही सनलाईट आहे, इट इज इन द फॉर्म ऑफ ए plane wavefront, because plane wavefront is at a infinite distance. Okay, then second one, in a Young's double slit experiment, if there is no initial phase difference between the light from the two slits, a point on the screen corresponding to the fifth minimum, what is the path difference? Then you know the relation for path difference, del I is equal to the 2n minus 1 into the lambda by 2, because this is the condition for minimum, or this is the condition for a dark band. Okay, here dark band is the fifth dark band, therefore put the value of n, therefore 2 into 5 is minus 1 into lambda by 2, therefore it becomes the 9 lambda by 2. Okay, then next, two coherent sources whose intensity ratio is 25:1 produce interference fringes. Calculate the ratio of amplitudes of light waves coming from them. Okay, here we have given the intensity ratio of two coherent sources. I1 is the intensity of the first sources, I2 is the intensity of the second sources. Therefore, I1 upon I2 is equal to the 25 upon 1. Okay, and calculate the ratio of amplitudes of the light waves. We have to calculate the A1 upon A2. You know the relations between the intensity and amplitude. Relationship between intensity and amplitude is intensity is directly proportional to the square of the amplitude. Therefore, equations becomes I1 upon I2, which is equal to the 25 upon 1, which is equal to the A1 square upon A2 square is equal to the A1 upon A2 is equal to the 5 by 1. Okay, therefore answer is 5 by 1. Then next one, why two light sources must be of equal intensity to obtain a well-defined interference pattern. You know that there are some conditions to obtain the steady well-defined interference pattern. त्यामधली एक कंडिशन अशी आहे की two light sources must be of equal intensity. This is because only if the intensities of two light sources are equal, the intensity of dark fringes is 0 and the contrast between bright and dark fringes will be maximum, and therefore it will give rise to a well-defined interference pattern. कारण त्याच्यामुळं काय होणार आहे की लाईटची इंटेन्सिटी जर इक्वल असेल तर इंटेन्सिटी ऑफ द डार्क फ्रिंजेस विल बी द 0 and there is a good contrast between the bright and dark fringes. You can distinguish which is the dark band and which is the bright band. Okay, then next question, what is the relationship between the phase difference and optical path in terms of speed of light in vacuum? Okay, solution. Phase difference del phi is equal to the omega upon c into the n into delta x, where omega is the angular frequency, c is the speed of light, and n delta x is the optical path for a wave traveling in the medium of refractive index n. Okay, this can be calculated from equation phase difference is equal to the 2 pi upon lambda into the path difference. Then it is equal to the 2 pi n upon n lambda. Divide and multiply equation small n to both the side, both the numerator and denominator into the path difference. Therefore 2 pi n is the omega and n lambda, what is n lambda? N lambda is the c. Therefore you get the same equation, phase difference is equal to the omega by c into the path difference. Okay, then next one, why should be the slit width to obtain the pronounced diffraction with a single slit illuminated by the light wavelength lambda? Solution, to obtain the pronounced diffraction with a single slit, the slit width should be order of wavelength lambda. It is the important conditions to obtain the diffraction pattern. Okay, then last question, what must be the ratio of the slit width to the wavelength for a single slit to have the first diffraction minimum at 45 degree. Here we have to calculate the ratio of slit width. What is the slit width? Slit width is the A and wavelength is the lambda. Therefore, we have to calculate the A upon lambda. And we have given the minimum diffraction at 45 degree. Therefore, for first minimum we get the sine theta 1 is equal to the lambda upon A because n is equal to 1. Therefore, for theta 1 is equal to 45 degree, sine 45 is equal to the 1 upon root 2. Therefore, 1 upon root 2 is equal to the lambda by A, and therefore A upon lambda is equal to the root 2 as to 1. Therefore, ratio of slit width to wavelength is equal to the A upon lambda is equal to the root 2 upon 1. Thank you.